Calculating pH for weak acid or base solutions. In this problem it says, what is the pH of a 0.375 molar H3BO3 acid solution? The Ka equals 5.8 times 10 to the negative 10th. What we have to realize is H3BO3 is a weak acid, so boric acid is going to not dissociate completely. So what this means is that we're going to use the Ka value to understand how much it dissociates. And we know that it's going to dissociate into H positive ion and an H2BO3 negative ion. And then we're going to put that over the H3BO3 acid. So we know the concentration of this, but we know it's going to diminish over time. So this is what we're going to write so that we can solve our problem. We have X because we know the concentration is going to change a certain amount X and then going to change a certain amount X for this as well. So it's going to be the same. So we have X here times X because these, so when we solve for X, X is going to be the concentration of H plus and the concentration of H2BO3 over 0.375 minus X, which is part of it that's leaving, that's being turned into H positive ions and H2BO3 negative ions. Now, because this is a less than 5% change in concentration, we can just approximate this to be 0.375, and then that's going to divide X squared. So X times X is going to give me X squared, and because I did this approximation, it's going to give me 0.375 because it's going to be a very small takeaway from the concentration. So now I'm going to, what my Ka value is 5.8 times 10 to the negative 10. So I'm going to use that so I can solve for X. X then, when I solve for X, X becomes 1.47 times 10 to the negative 5th molar concentration, and that equals also the concentration of H positive, like we said up here. So to figure out the pH, all we have to do is negative log of the concentration of H positive, which is going to equal negative log 1.47 times 10 to the negative 5th molar is going to equal a pH of 4.83. And so that means that E is the answer to our question.